This empty grid is arguably the most scrutinized piece of real estate in a software engineer's career. When a recruiter or collaborator looks at a GitHub profile, the eye goes dead center to the contribution graph. It is the default metric the industry uses to judge consistency, discipline, and sheer output. But that visibility cuts both ways. Taking time off between jobs, spending a month reading documentation, or stepping back to study basics doesn't generate commits. To the algorithm, and the hiring managers relying on it, a blank grid looks like a sudden drop in activity. The logic gets even worse for enterprise developers. If you spend 40 hours a week writing proprietary code inside a closed corporate network, none of that work pushes to your public profile. The graph stays dark, masking high-level engineering behind a facade of complete inactivity. The empty squares rarely mean a developer stopped building. They expose the reality that the industry relies heavily on performative signaling, where proving you wrote code is treated as more important than the code itself. SyncGraph was built to bridge that exact visibility gap. It is a deterministic background engine, represented here by this continuous feedback loop, that automates daily learning log commits directly to your public profile. Instead of requiring you to manually push empty files to keep your streak alive, a Python-based background worker wakes up every day, writes technical content, and pushes it to a repository completely under your control. It achieves this by generating technical markdown entries drawn from curated pools of software development topics. This builds a persistent library of industry-standard learning notes, replacing generic updates with content that mirrors professional documentation. Because the bot acts as an authorized client pushing real text files to a real codebase, it operates strictly within GitHub's terms of service. You get a documented history of technical topics that the platform systems correctly register as valid daily activity. By handing the burden of daily commits over to an autonomous service, developers strip the anxiety out of maintaining their public footprint. The graph stays active, leaving you free to focus entirely on deep work or taking a well-earned break. Granting an external service the ability to push code on your behalf creates a technical challenge. A compromised connection exposes your repository to malicious injections. The system operates on a minimum viable permission model. When authenticating via GitHub OAuth, the access scope is restricted to the repo permission. The moment that token reaches the backend, it hits a cryptographic wall. The system applies AES 256 GCM encryption, using a fresh 12-byte initialization vector to scramble the token. When the daily job triggers, the token is decrypted just long enough to authenticate. The millisecond the push is confirmed, the raw token is wiped entirely from local memory. This architecture eliminates the severe risk associated with legacy tools that require developers to manually copy and paste personal access tokens into unverified web forms, exposing raw credentials in plain text. What you are looking at is the terminal handshake. It is a visual representation of that highly restricted data tunnel operating autonomously in the background. Without this level of cryptographic discipline, automating commits would be deeply irresponsible. The entire system is viable specifically because the architecture protects the developer's digital identity at every layer. With the connection secured, the daily operational logic takes over. The engine relies on a persistent job scheduler running inside an asynchronous Python framework to process every active user on the platform. This timeline visualization demonstrates how the scheduler breaks away from rigid background scripts. Rather than pushing code at exactly midnight, it randomizes execution within a user-defined time zone window. Commits fall at unpredictable intervals, mimicking the organic workflow of a human being. When the randomized timer fires, the content generation script takes over. It selects topics from curated message pools, generating distinct markdown files each day. You never end up with 50 identical commits reading bot update. If the GitHub API goes down or a network timeout occurs, the system utilizes exponential backoff, waiting longer between each of its 3 retry attempts to ensure temporary server hiccups don't ruin a hard-earned streak. The careful randomization of timing and content, backed by robust error handling, creates a dense, credible history of work that requires zero daily oversight. The user experience is a 3-step onboarding flow. You connect an account, choose your commit frequency, and with a single click, launch the automation process. The result is immediate visual proof of consistency. Over weeks and months, the barren grid fills in, creating a dense, bright green heat map of continuous daily activity. This simple visual change eliminates a major source of career friction. Knowing your profile projects constant, disciplined output allows you to enter job negotiations or pitch projects with an active footprint already established. You maintain full administrative authority through the dashboard. At any point, you can adjust the daily commit volume, shift the active time zone, or point the bot to a completely different private repository. SyncGraph converts the variable nature of manual commit rituals into a reliable background process. It builds a consistent digital history that continues to scale while you focus on higher-level engineering. SyncGraph is part of a much larger architectural vision. It operates as a core utility within the Omni IDE ecosystem, a suite of tools engineered to optimize the modern developer's workflow. Maintaining a visible, public-facing engineering profile is a baseline requirement in a competitive job market. Automating that presence ensures you are always prepared for the next opportunity. Scan the code on screen or head over to the URL to join the waitlist and move your daily contribution cycle to the background. Your energy belongs in the code base, solving actual engineering problems. Let the engine handle the signaling, so your commitment is always recognized.